Hey guys, we're back at it with another video. My hand is a lot better than it was. I still kind of injured, but I have some movement right now. So we're back at it. All right, absolute value functions. What we've been learning in class. Anyway, this video should feel like review. I'll be a bit fast, but of course, if you don't understand anything, please come and see me in my Highland Advocate hours. So, what is an absolute value? Yeah, what is this? Well, this is the distance from zero a number is. All right, how far from zero a number is on the number line. So these vertical bars, when you see the vertical bars around the number, that means we're asking about the absolute value, right? So, what's the absolute value of 2? Well, we look at our number line and go 1, 2. So that's 2, right? Absolute value of 2 is 2. What's the absolute value of negative 2? We go again, 1, 2, distance from 0. Absolute value is, oops, I put negative. It's just regular 2, right? Same thing here, negative 1. Let's put negative signs. Let's go take one step from 0, and that's going to be 1. Here I take another step, here I take a step from 0, and it's going to be 1, right? But here, take 3 steps to the left, so that's 3 steps. It's going to be 3. I can take 3 steps to the right, and it's going to be 3. So what? And here we've clearly seen one thing, all right, in getting absolute values. Absolute values are always positive. All right. So we see again the absolute value of a negative number. All we're doing is counting the steps it is from 0, and those steps are positive. So yeah. So yes, we've done this in class. I actually want to solve a few of these for you, just for you to just get a gist on how to go. So it says, in our own words, explain what absolute value is finding, or the distance from 0. What are some real world scenarios in which you might use absolute value? Well, some real world scenarios. Gain the shoe size. Yeah, I put this one already. Like the shoe size is always positive, right? Regardless of whether it's facing the positive direction or the negative direction. All right, now let's talk about simplifying expressions. What's absolute value of 19? This is just 19. Absolute value of 16 minus 13. Well, we always solve what's in the absolute value first, all right? Always solve what is in the absolute value bars first. All right, so this is going to be 16 minus 13, which is going to be, so that's going to be 3. Yeah, 16 minus 13 is 3. I've solved what's in the absolute value bar, and then this is absolute value of 3 is just going to be positive 3, right? And the same thing here. I solve what's inside first. So 2 minus 3 times 4, that's 12, right? And then outside, we got minus 6. I continue solving what's inside the absolute value bars first. 2 minus 12, it's going to be minus 10, minus 6. I solve what's in the absolute value bar here still again. And it's asking me what's the absolute value of negative 10. The absolute value is equal to 10. 10 minus 6 is going to be equal to 4. All right? And let me do one more here. This is a bit of a trickier one that we faced in class, but still, just keep solving what's in the bars first. All right? So we see what's inside this bar. We got minus 14 minus 29. This is going to be negative 43. All right, we still have the absolute value bars. There's a minus sign outside, and then here, this is asking for the absolute value of negative 12. Well, that's just positive 12. We have our negative outside, so the negative stays there. So what's the absolute value of negative 43 now? Well, that's just going to be 43. Over negative outside, so negatives outside, then we put the absolute value of negative 43, which is just 43. And then we put our minus sign, and everything else stays the same. It's going to be minus 55. All right, so a good rule of thumb to get you through these is to solve what's in the absolute value bars first, and then deal with everything outside later. All right, so yeah. Now, the general forms of absolute value function. All right. Now we're transitioning from simplifying to graphing absolute value functions. So this right here is what an absolute value function looks like. All right. X here is just a variable, the independent variable, but A, H, and K are all important coefficients. So A here is the slope in both directions. And by both directions, I mean the negative direction and the positive direction. All right. If you've noticed, our absolute values look like that. Absolute value functions look like a V. So the slope, the positive slope, will have a particular number, like 1. The negative slope will have a slope of negative 1 or so. This is an example. But they're both the size 1. They both have the magnitude of 1. So the slope in both directions, like how much you should rise over run to make this line, is A. All right, A will always tell you that. Okay. So next, H. H is the x coordinate of the vertex. The vertex is just where the lines meet, where the two lines meet. You know, because of our V, this point here, that's the vertex, right? And X is the x coordinate. Sorry, and H is the x coordinate of the vertex. And with H, a note is always multiply H by negative 1. Always, all right? Because you see, here we're asking about minus 8. The general form here has a negative sign. So we always have to multiply by negative 1. And K is a positive sign, so we don't have to multiply by anything. It will take on whatever number is plugged in for K. But K is just the y coordinate of the vertex. All right? So the vertex will always be somewhere on the axis. It will always be somewhere on the axis. And where it starts from, all we need to know is where the vertex is and what the slope is to graph our absolute value function for any particular linear function. That's why it's pretty easy. So now this is a few graphs we've graphed before already. I'm just gonna run through them. So I've put our general form right here. We have absolute value bar x, absolute value bar, right? So what we do here now to begin graphing is find out where our vertex starts from. So we said H and K tells us where our vertex is, where H is the x coordinate and K is the y coordinate. And we always have to multiply H by negative 1. So in this case here, our function is f of x equals absolute value bar x. What's H and what's K? Well, here I can clearly see that it's 0, 0. All right. And then what's A? A is 1. All right. A is 1. A is 1. Why is A 1? Well, because this is a multiplicative identity. That's what it's called. When you multiply a number by 1, it will always be that same number. So here, if I multiply 1 by the absolute value of x, it will just be the absolute value of x. I'm not changing anything. So think about every number inherently, you can always assume it's multiplied by 1. but it's just very unnecessary to think about multiplying by 1 because it's constantly being done. But yeah, so here in this case, a is 1. So I know my vertex is at 0, 0. And a, my positive slope is 1. So I just rise over around 1 each time. Rise over around 1. And my negative slope is 1 as well. Just rise over 1, rise over 1. And boom, I've graphed my function. All right. All this stuff here, I won't do it. I'm gonna focus on graphing. But if you care, the domain is infinity. Infinity. The range is 0 to infinity. Oh, we exclude infinity always. Apologies. X-intercept 0. Y-intercept 0. 1 to 1. No fails horizontal line test. Onto, well, if our codomain is all real numbers, so codomain all real, so it's going to be no, even or neither. I'd say even. And piecewise function, too much time. All right, so now this one, let's graph this function here. Yeah, so let's put our general form somewhere just to help us think about this function. Yeah. Oh, I didn't have this in my general form. XH plus K. So here, what's my K, right? Like, remember, all I need to know is what my K is, what my H is, and what my A is to graph my absolute value function. So what's K? K is -3. That's my y-axis, right? So I know that my vertex is at y equals -3. Yeah. Then what's h? Well, h here in this case is -1. All right. I know here we are seeing +1, but remember what I said. We always have to multiply x we always have to multiply h by -1 because of the negative sign in the general form. All right. So what this really is a -1. So we draw another line, and where they meet is where the vertex starts from. All right. And what's a? A is 1. So I just rise over 1 in the positive direction and the negative direction. All right. Let's go, and that's how it is. All right. So all I need to know is my K, my H, and my A to make this function. So A is the slope. We rise over around 1 time. H is the x coordinate of where the vertex is, and K is the y coordinate. Now, what about this one? So this one is very interesting. All I can tell you is every time you see a function looking like this, all right, isolate x, all right? Isolate x. Always have x alone, as I like to think about. Always try to have an expression that looks like x minus 2, all right? So, and how would I do that for this function? Yeah, my function is, like, I would say, my function here is g of x equals 1/2 x minus 2, all right? So if I want to isolate my x, I can treat these absolute value bars like brackets and factor it out. It's going to be 1/2 x, all right? I'm factoring out. I'm just simply factoring out. So I don't want to change the function. I just want to factor out the 1/2. So what can I multiply by 1/2 to get 2? And that's 4. So you see, this is the same function. I haven't changed the function at all. I've just factored the 1/2 out to isolate my x. But if I put it back in, you see 1/2 times x to 1/2x, and 1/2 times 4 will be 2. All right. But this is an easier way for me to think about it. So now I have it in this form. What's my A, what's my H, and what's my K? My A in this case is 1 over 2. All right. So I rise 1. I rise 1 and run 2. All right. And my H is positive 4. So H 1 over 2, K positive 4. And remember, why is it positive 4? Because of the general form. The general form has a minus sign before the H. That's why. So, and my K is here. K is normally added to something, but we see we're not adding anything, so that's just 0. So, I know where my vertex is, HK. So, 4, H is where the x-axis is, 4, and y is 0. So, it's right there. And my slope in both directions is 1/2. So I rise 1, run 2, rise 1, run 2, rise 1, run 2. All right, same in that direction. Although our axis is not big enough, but you get the idea, right? I hope so, at least. And yeah, there's our function. So always isolate. Now what happens if x here is negative, right? He says consider the equation. How will the graph of this equation differ from the other examples? Well, you see, if I have a negative there, so it's basically saying if A is negative, right? If A is negative, if A in our general form is negative, this would, like here, our graph will no longer be an open V. Instead, it will be an upside down, our graph will no longer be a positive V. It'll be more like a triangle, really. It'll face downwards, all right, because of the negative sign. And if I graph this function here, absolute value of the negative of the absolute value of x plus 3. Well, if I pull up my general form, I put my general form here, so I can see what my HK and A look like. What's A? Well, A here is -1, all right? And then what's H? H is 0. I don't have an H. And then my K is 3. So if I go to 3, and my K is a y-axis, so 3, x 0, y is 3. So I go there. And then a slope of -1. So it just points down as a V. So I'm going down, rise over run. So I'm rising and going to the left. And this is my function. Instead of normally, as we know, it would be an open V read, what we've learned, but with a negative sign makes it makes it face down. The negative sign, all the negative sign does, the negative sign makes the function face down. All right, that's all for this video. I don't want it to be too long. I hope you guys found it interesting and at least helpful review for this segment of the class.